guys, Miss Miklos here, and today we are covering section 6.3, and we're going to be dealing with different operations with polynomials. So before we start talking about operations, which we know are like addition, subtraction, multiplication, etc., we're going to go ahead and focus more on polynomials. We spent a lot of time in our last lecture classifying them by type, but today we're going to classify them in a different way. Our first type of polynomial is a monomial, and that's when we only have one term. Some examples of this would be things like 6x squared, negative x, 5. Any of these three different polynomials, we notice there is just one single term. When we have two terms, we call it a binomial, and you guys have heard that a lot before. And some examples of this would be things like x plus 2 or 5x squared minus x. And what really makes the difference in these is the idea that my terms are separated by plus or minus. So I notice here I have x plus 2. X is a term, 2 is a term. Over here, 5x squared is a term, x is a term. It's separated by this subtraction. Here it's separated by that addition. Okay, so that's how we can really separate terms, is by looking at addition and subtraction. Our next type of polynomial is what we call a trinomial, and that's when we have three terms. And we dealt a lot with this when we were dealing with factoring. So an example of a trinomial would be x squared plus 2x minus 6. Notice our terms are separated with addition and subtraction. Okay, so whenever we use the term monomial, binomial, or trinomial, we're referring to how many terms are actually in our polynomial. When we're dealing with polynomials, it's really important just that we remember what a like term actually is. And a like term is when we have the same exact variable or variables to the exact same degree. So some examples of this would be x squared y and negative 2x squared y. Okay, we both have an x and a y, so we have the same two variables, and our variables are being taken to the same power. So those would be like terms. Unlike terms are the same idea, so it is when we do not have the same variables to the same degree. So an example of this would be something like 5xy and negative 2x squared y. Notice I actually have the same variables here, but these are not like terms, or they are unlike terms, because this x and this x have different exponents. They have a different degree. Okay, so these would not be like terms. The reason why like terms are important is because today our problems are going to be simplified when no two terms are alike. And we really do this naturally when we add all of our like terms together. But that is always going to be a check for us when we're done with our problem. Before I give my final answer, I need to verify that no two terms are alike. The first concept we're going to talk about today is finding the degree. And we've worked a lot with degree, but mostly when we had a single variable, which makes it pretty easy. For example, if we had something like 2x squared, my degree here is 2, because my exponent is 2, and that is the term that has the highest exponent, because this is the only term in that particular polynomial. We've also dealt with problems like this, where I have a trinomial, and yes, we do have x's and y's, and that's okay. This isn't necessarily a function per se, but I just need to look and see what is the highest degree. And to me, this term looks like it has the highest exponent, which is 4. So I'm going to go ahead and say our degree is equal to 4. Now this is the one that can get a little bit tricky. So what we're going to have to do, since I have more than one variable in a term, I'm going to have to add the exponents in each term. Then I'm going to look at all my terms and choose the highest number. Okay, so for example, this first one is just going to be 2 because all I have is this squared. Our second one would actually be 3 because I have 2 plus 1. Next I would have 2, and that is because this would be like 1 plus 1. And lastly, I have 2 because of the squared. So looking at those, I think we would all agree that 3 is our highest number, so we would say that our degree there is equal to 3. One final one. Here I just have a single term, but I do have more than one exponent, so when I add those exponents together, I would get that our degree here would be 5. Okay, so key thing, I'm adding the exponents in each term, then I'm comparing the terms and I'm choosing the highest number. Now we're going to get into our actual examples, and our directions are all going to be simplify. And our first problems are going to be something like this, where I'm adding two polynomials together. And we will see it sometimes written like this, where I have my like terms in columns, and sometimes I will see it written as a polynomial plus or minus another polynomial. And it really doesn't matter. This way is kind of nice visually because I can add my like terms in our columns together. So first thing, 3x cubed plus x cubed is going to become 4x cubed because I'm adding those coefficients together. Negative 2x squared minus 10x squared is going to become negative 8x squared. Negative x plus negative x is going to be negative 2x. And negative 7 plus 1 becomes negative 6. Now if I look at this polynomial here, we may notice that none of these are like terms, so that means that this would be our final answer. Okay, if I still had 2x cubed terms or 2x squared terms in this answer, then I know that there's more that I would need to do at that point in time. On example number 2, once again, we are simplifying, and I want to point out that this is not a multiplication problem because it just says plus in the middle. So I'm going to add all my like terms together. And I notice that I don't have any other x cubed, so it's just going to be 9x cubed. I also don't have any other x squared, so it's just 5x squared. Now I'm going to combine negative 2x plus 12x, which becomes 10x. 1 plus negative 4 becomes negative 3. Looking at this, I do not have any like terms in this answer, so I know that this is our final answer. Okay, so problems like this, all I'm doing is adding our like terms together. Number 3, we're moving on to subtraction here. And one thing we may remember is that subtraction simply means I am adding the opposite. So on a problem like this, the first thing that I may go ahead and do is change this into a plus and kind of distribute this negative to everything. So I went ahead here and just wrote plus, and I really changed all these signs because I'm adding the opposite. So when I combine my like terms, I get 6x cubed minus 9x squared minus x plus 8. Number 4 is another subtracting problem, and when we write it out horizontally like this, the first thing I always do is distribute the negative, and then I know I'm really just adding. So I have 2x squared plus 3x minus 3x squared minus x plus 4. So if I'm looking at my like terms, 2x squared minus 3x squared becomes negative x squared. 3x plus negative x becomes plus 2x, and then I have plus 4 as my answer. This is my final answer because all of my terms are combined. I don't have any like terms left over in my answer. I also want to point out that we wrote our answer, and we really have done this on all of our examples. We wrote our answer in descending order, which means my highest degree is first, and it decreases from there. Moving on to number 5, this time I don't have addition or subtraction between, so I know this is multiplication. And the first thing that jumps into most of your minds is FOIL. However, we actually only use FOIL when I'm dealing with multiplying two binomials together. Here we have a binomial and a trinomial. And all FOIL is, it really is a way for us to make sure that we are distributing everything. So what I'm going to do here, I'm really going to think of this as distributing. So I'm going to start with x. Okay, so I know that x times 3x squared becomes 3x cubed, because we learned in a previous lesson, I add those exponents together. X times negative 2x is negative 2x squared. X times negative 4 is negative 4x. Now I need to move on to distributing this negative 3. Negative 3 times 3x squared is negative 9x squared. Negative 3 times negative 2x is 6x. And negative 3 times negative 4 is 12. So now I need to look at this and add all of my like terms together. So I have 3x cubed minus 11x squared plus 2x plus 12. And it looks as though this is our final answer because all of my like terms are added together. So all we're doing here when I'm multiplying more than just a binomial and a binomial is just a fancy way of thinking of distributing. So I'm distributing each term in that first parenthesis to each term in the second parenthesis. On number 6, we are actually multiplying 3 terms together. So what I need to do, I need to choose 2 of these binomials that I want to multiply together first. And it quite honestly doesn't matter. I'm just going to choose those first 2. So when I FOIL those, I get x squared plus 4x minus 4. And then I still have that x plus 3. And I'm going to combine my like terms here, and I get x squared plus 3x minus 4 times x plus 3. So now we have a trinomial times a binomial, and I'm going to distribute each term at a time. So x squared times x is x cubed. X squared times 3 is 3x squared. 3x times x is 3x squared. 3x times 3 is 9x. And lastly, negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. So now I'm going to add all my like terms together, so it looks like we have x cubed plus 6x squared plus 5x minus 12 as our final answer. Number 7, I have 4n minus 5 times the quantity 4n plus 5. So you may remember from our previous chapter that this is actually our difference of squares pattern. When I have the same 2 terms and the opposite sign in between, it is really our product is the first term squared minus the second term squared. And if I forget about this shortcut, remember I can always FOIL this out. Okay, so let me just kind of show you. If I FOILed this out, I would get 16n squared minus, or I should say, plus 20n minus 20n minus 25. Notice that these 2 middle terms cancel out, so I'm left with 16n squared, which is 4n squared, minus 25, which is minus the quantity 5 squared. So this is our final answer. So I quite honestly don't care if we use this pattern or if we FOIL it out. Do whatever is easiest for you. Number 8, we have the quantity 9y minus x squared squared. And you may recognize this as one of our perfect square trinomials, which is another pattern that we learned last chapter. Once again, what this is telling me is it's the first term squared plus double the product of the 2 terms plus the second term squared. Okay, and that's really what both of these are saying. Now, if I forget this pattern, I can always use FOIL. So the first thing I'm going to do here is write it out as 9y minus x squared times 9y minus x squared, because I know squaring something means I'm multiplying it by itself. If I FOIL this, I would get 81y squared minus 9x squared y minus 9x squared y plus x to the 4th power. Okay, so if I'm looking at this, I notice that these two terms are like terms, so I can write 81y squared minus 18x squared y plus x to the 4th. Now at this point it does not look as if I have any other like terms, so that's going to be my answer. And let's just look at this for a second. 81y squared is the quantity 9y squared. Negative 18x squared y is double the product of 9y times negative x squared. And x to the 4th is the quantity x squared squared. The other thing I want to point out here is this is actually written in descending order, even though you may not think it is. This time it's written in descending order in respect to y. So if we notice y squared, y to the 1st, and then I don't have a y, so that would be like y to the 0. If you guys wrote this in the opposite direction, that would be correct also, because that is in terms of x. Okay, so number 9, we are doing something here where we are actually cubing a binomial. And in pre-calculus, you guys will actually learn something called Pascal's triangle that can help us out with these coefficients. And it can save us a little bit of time. But today we are just focusing on multiplying. So I'm multiplying that out 3 times. And I'm just going to focus on 2 of them to FOIL together. So AB times AB is a squared b squared. AB times 2 is 2AB. 2 times AB is 2AB. 2 times 2 is 4. And now I have times AB plus 2. So this becomes a squared b squared plus 4AB plus 4 times AB plus 2. And now we're going to continue with that concept. A squared b squared times AB becomes a cubed b cubed. A squared b squared times 2 becomes 2a squared b squared. 4ab times ab becomes 4a squared b squared. 4ab times 2 becomes 8ab. 4 times AB becomes 4AB, and 4 times 2 becomes 8. I worked that out perfectly there with my writing. I'm so proud of myself. Anyways, now I need to look and see if I have any like terms. A cubed, B cubed does not have any like terms, but I notice these next 2 terms are exactly the same. So I get 6a squared b squared plus, our next 2 terms are the same, so 12ab plus 8. So this would be our final answer. Okay, final example of the day. I saved the best for last. A trinomial times a trinomial, but I know we can do it. So let's get into it. X squared times x squared is x to the 4th. X squared times 4x is 4x cubed. X squared times 2 is 2x squared. Now moving on to negative x. Negative x times negative x times x squared is negative x cubed. Negative x times 4x is negative 4x squared. Negative x times 2 is negative 2x. Negative 3 times x squared is minus 3x squared. Negative 3 times 4x is negative 12x. And negative 3 times 2 is negative 6. That one didn't work out quite as pretty, but that's okay. Now I need to combine my like terms. I notice this is my only x to the 4th term, so I'm going to just write x to the 4th. And when we have something like this, sometimes it's helpful if we cross it off when we're done with it so I know that I already added it. For example, here my x cubed terms, I have 4x squared minus 4x cubed minus x cubed, which is 3x cubed. So that way I know I dealt with them, they're out of the way. Next one, my x squared terms. 2x squared minus 4x squared minus 3x squared becomes minus 5x squared. My x values, when I combine those, become minus 14x And then last, I have minus 6. So this is our final answer. I notice none of my terms are the same. So hopefully this has been a good recap of Algebra 1 skills with adding, subtracting, and multiplying polynomials.